Hey class, some of you were asking me about question number 63 on the homework, so I thought I'd make a quick video for you guys. In this problem, we're asked to determine the mass of this particle that is what I've labeled as Q3. So we're trying to determine what is the mass here of this particle. I'll call it M3. And what we're given is the charge and distances between our different particles, and we're also given the acceleration of particle 3 once all of these particles are released from rest in this setup that we see here. So our acceleration is 120 kilometers per second squared. Okay, so that's cool, looks good. But the question is, why are we looking for mass? We've been learning about Coulomb's law, which is usually dealing with forces and charges and different things. So let's think about that for a minute. We want to find the mass, and we know from Newton's second law, good old review from first semester, that the net force acting on an object is equal to its mass multiplied by its acceleration. So if we want to find the mass of this particle 3 here, it's going to be equal to the net force acting on particle 3 divided by the acceleration of particle 3. Okay, that's cool. So if we can figure out what the net force is, then we should be good to go. So if we draw a free body diagram over here for particle 3, what kind of forces do we have acting on it? Well, we see that next to it, Q1 is going to exert a force, and the force from Q1 will be in the positive x direction. Since they have a like charge, they will repel one another. So we'll have the force from particle 1. The force from particle 2, since they are opposite charged, will be an attractive force, so it too will generate a force in the positive direction as well. And so we have two forces due to Coulomb's law that we can use to describe the net force, or to determine the net force acting on our particle 3. Okay, so let's just sketch out what that net force would be. Real quick, let's just note up here, I'm going to be talking about our distances between our objects. So we're going to have here, this distance I'll call R1, and this distance here I'll call R2. And we can observe, maybe I'll just make a note of it here, we can see that R1 is just going to be 0.35 meters, and then R2 is going to be the distance, 1.04 minus 0.35, the distance in between those two. So R2 should come out to be, I believe, I don't have my calculator, but it looks like 0.69 meters. Okay, so if we want to find our net force then acting on our object, our particle, it's going to just be the sum of all the forces acting on it, F1 plus F2. So scroll down a little bit. So really we're just going to have the net force will just be equal to K Q1 Q3 over R1 squared plus K Q2 Q3 over R2 squared. And again, keep in mind we're looking at magnitudes here for all of our forces, or all of our charges. Okay, so once you get, sorry that's a little sloppy, but I think you guys understand what I'm saying, but once you get the net force there, you can just pop it in up here, and you should be able to determine the mass. The key here, though, is you must be very careful with all of your units, alright? So I think some people may have gotten in trouble strictly just with units, because keep in mind, as you can see, we're given kilometers per second in our acceleration, so we need to multiply that by 1,000 to get to our actual meters per second. We have microcoulombs, so we need to put that times 10 to the negative 6th to get to coulombs, and I already changed our centimeters into meters. So check your units, plug in, and you should be able to get a box-worthy mass for your particle. Go team. Have a good day.